What we're doing today is solving for the height of a cliff using right triangle trigonometry. This is a particularly difficult problem because I don't know how far I am away from the cliff at the initial measurement here. I'm going to start off at point C, measure a 60-degree angle of elevation, which if I'm going to set up an equation is going to be the tangent of 60 since x is the opposite side and y is the adjacent side. The thing is I don't know anything about x or y, so I can't solve for the other variable. So then what I'm going to do is back up another 50 meters, and I'm going to measure again. This time I'm measuring 30 degrees. Across from that is the opposite side, which is x, but this time the adjacent side is, I don't know how long, but it is 50 more than it was before, 50 plus y. So my equation is going to be tangent of the degrees, which is now 30, is equal to 50 plus, or x over 50 plus y, which is the opposite over the adjacent side. Now I have two equations here with two variables. What I need to do is set up a system of equations, and I'm going to solve both of these equations for x, because that's easy to get by itself. Simply multiply both sides by y, and this will cancel out, leaving me that x is equal to the tangent of 60 times y. And then I can do the same thing on the other side, but not just multiply by y, but multiply by 50 plus y. That'll cancel out, and I'll have x is equal to 50 plus y times the tangent of 30. Now, since these two equations are both set equal to x, that means they must be equal to each other, so I'm going to go ahead and set them equal to each other. Tangent of 60 y is going to be equal to 50 plus y times the tangent of 30. This will be an equation that I could actually solve because now I only have one variable that I'm going to have to solve for. The problem is it's going to be kind of ugly because we have all these sine, cosine, and tangents involved with the problem. So what I'm going to have to do is just go ahead and start calculating out a decimal version of what they are. So I'm going to say the tangent of 60 and figure out that that is 1.73. So 1.732 would be the tangent of 60. That's still being multiplied by y, is equal to 50 plus y times, and then I have to figure out what the tangent of 30 is. So tangent of 30 is equal to 0.5774. So 0.5774. Now what we have here is just a basic equation that we have gotten rid of all the tangents from, so it's now pretty simple. We want to use the distributive property and multiply the 0.5774 times y and by the 50. So I'll have 0.5774y plus, and we have to figure out what this 0.5774 times 50 is, which is going to be 28.87. 28.87 is equal to, and we still have this 1.7321y over on this side. Now, if I'm going to keep doing this problem, I need to get my like terms on the same side, so I'm going to subtract the 0.5774y from both sides, minus 0.5774y, and then we just have to calculate that. 1.7321 minus 0.5774, and that will get me 1.1547. 1.1547y is equal to, and then we have the 28.87 on this side still. Now, of course, we still have a regular equation. I just need to solve for y by dividing both sides by 1.1547 divided by 1.1547, and then that will be my simple calculation, 28.87 divided by 1.1547, and that'll get me what y is. So y is 25. That is the distance I am away. That's not what I'm looking for. What I'm looking for is to find the actual height, the height of the cliff. I know that this is now 25. Now, in order to find the actual height of the cliff, what I need to do is plug the y into one of the original equations. I'm going to choose this equation up here, tangent of 60 is equal to x over y, because that's the simplest thing to solve for. Tangent of 60 is equal to x, which I don't know, over y, which is now 25, and then all I have to do is calculate that. Simply multiply both sides by 25, that'll cancel. 25 times the tangent of 60 will be my x. X is equal to 25 times the tangent of 60. So I just calculate that out. 25 times tangent of 60, and that'll get me 43.3 feet.